Hello students, hi, welcome back. I hope you are doing good. So in this part, we'll be discussing about the physical properties of your alcohols, phenols and ethers. Have you ever wondered why a 1 degree alcohol is having higher boiling point than your 3 degree alcohols or tertiary alcohols? The answer for this question, lies in this part. So why to waste our time? Let's start with this part. Physical properties. So in the physical properties, we'll be discussing about the physical properties of alcohols, phenols and ethers. First of all, physical properties of alcohols. Aliphatic and low aromatic alcohols are liquids at room temperatures. Highly branched alcohols with 12 or more carbon atoms are solids. For a given molecular formula, the order of boiling point is 1 degree alcohol has higher boiling point than 2 degree alcohol than 3 degree alcohol. What is the reason? The reason is simple. As you go on from 1 degree to 3 degree alcohol, the structure surface area decreases, and as the structure surface area decreases, its boiling point decreases. So boiling point of alcohols or phenols are higher than alkynes and haloalkenes or haloarenes of similar mass. Why? You have C2H5OH, you have CS2, CS2, CS3 and CS3Cl. But C2H5OH has a higher boiling point. The reason is simple, because of your hydrogen bonding. So the reason for higher boiling point of alcohols is that you have the probability of having the hydrogen bonding, which actually increases the boiling point when compared to your alkyl halides or alkanes. So because of hydrogen bonding, you can see here. So what type of hydrogen bonding? You have an intermolecular hydrogen bonding between a molecule and a molecule. So for alcohols, boiling point decreases with increase in the branching of carbon chain, and because of surface area decrease, hence van der Waals force decreases. So boiling point always decreases with a decrease in the surface area. So solubility of alcohols. Alcohols with short alkyl group dissolve in water. So solubility of alcohols decreases sharply with the increase in the length of alkyl group. The logic is again same. If the length is increased, what is happening? Its ability to form hydrogen bonding decreases, right? If the surface area decreases, ability to form hydrogen bonding decreases, and it affects the solubility. So solubility of alcohols decreases sharply with increase in the length of alkyl group. So higher alcohols are insoluble in water because of hydrophobic interaction. This actually creates a hydrophobic nature, which is nothing but anti-loving group of your water. So alcohols contains polar and OH group. This is actually hydrophilic, and non-polar end is the alkyl group, which is actually the hydrophobic. Solubility of alcohols. So polyhydroxy alcohols are more soluble than monohydroxy, as it forms more hydrogen bonds with water molecule. So solubility is again now depending on your hydrogen bond. So branched hydrocarbon increases the solubility of alcohol in water, because branched hydrocarbon causes the hydrophobic region and that becomes compact. So the important point is that van der Waals attraction decreases with decrease in surface area. Next, the physical properties of phenols. Boiling point of phenols. Boiling point of phenols are higher than alkanes and haloalkanes or haloarenes of similar molecular mass. Again, the reason is hydrogen bonding. So solubility of phenols in water. Alcohols and phenols with short aryl group dissolve in water. The solubility sharply decreases with the increase in length of the aryl group. The same concept because of increase in surface area. Next, physical properties of ethers. Boiling point of ethers are compared to the alkanes of comparable molecular mass and much lower than alcohols. So when I compare an alcohol and ether, the boiling point of ethers are lower than the alcohols. For example, you have an alkane, N-pentane. So you have ethoxyethane and you have butanol. So you can say that your boiling point is for ethane it is 309, for alkoxyethane it is 307, but your butanol it is 390. So remember, your ethoxyethane has a boiling point less than your alkane. So it shows that ethers don't have hydrogen bonding, which is present in alcohols. So students, in this part we learned about different physical properties of your alcohols, phenols and ether. We have discussed what happens to their boiling point, what is the importance of surface area of a given structure on the boiling point. So in our next part, we will be discussing about the important part, the chemical properties of alcohols, right? Till then, just stay tuned to our sessions. Have a good day. Take care. Bye.